short session, I'm going to show how to build a library. In this case, we have the blinking LED master, and we have several functions which belong together in the blinking master. That is, for instance, I2C init, I2C start, and so on. And later on, in one of the exercises, you probably have to add I2C read or I2C repeated start. So it would be nice if all these functions are clubbed together in a single library. In one of the first chapters of this entire course, I showed you this slide. So here we have the linker, which then creates executable code. In our case, the hello world. The executable code is generated out of the object code plus the runtime support library. What I would like is a library that comes from here, which contains all I2C functionalities, and together with the main, which sends a 1 or 0 over the I2C bus, combining in the linker and get executable code. The advantage is that I can write other programs and just combine the libraries into it to get I2C functionality. There are two different kinds of libraries. One of them is a static library, one of them is a dynamic library. Here we see again the difference. In dynamic linking, I just have a pointer to, for instance, printf, which then jumps to libc.so. So this SO stands for shared object. It's a dynamic library. Therefore, when the processor executes a program, it reaches this jumps into the library, executes the functionality mentioned here, and returns. In static linking, the code that is in the library is physically copied into your executable. That means there is no jumping to a shared object and returning from there. The big advantage of having dynamic libraries is that this functionality needs to be implemented only once, and all other programs which use printf can rely on this implementation. That means the file size for Hello World is smaller in this case. The advantage of static linking of libraries is that the entire functionality is integrated into the executable, and this executable does not rely on any external libraries. Since we do not have a file system on the Atmega, we cannot have a file called libc.so and supply it along with our upload. Therefore, we need our I2C library to be compiled statically into our executable. So let's get started. First, I make a copy of this program. So recursively, I copy the entire directory to blinking master, for instance, own library. The name is totally up to you. And now I start working in this directory. I create another directory called I2C, which contains all the files with I2C functionality. The next step would be to create several files which contain different functionalities. What I mean by this is, usually, if a developer uses I2C start, also I2C init has been used, and most likely also I2C stop has been used. Therefore, these three functions I include into one file. The developer might not have used I2C write, but for instance I2C read to read from slaves. Therefore, it is unrelated to I2C stop, I2C start, and I2C init, and I use a separate file for I2C write. It's good coding practice to have one file per function. However, since these three belong together, I2C stop, I2C start, and etc., I club them together in one file for demonstration purposes, which you will see in a minute or two. so that I don't have to rewrite the code, I just make several copies of the blinking LED master into I2C. So we have I2C, for instance, start, which contains my three functions, I2C start, init, and stop, and I have I2C write.c, which contains only I2C write. Let's remove the main and adapt the files. Let's start with start. So I don't have a delay, I don't have the ages. I can keep this, I can keep the frequency, I don't have the pull-ups. And this is my init, this is my start. This write I don't need here. Stop, and the main I don't need. I also need header files, which include the include directives, the define directives, and the function prototypes, which are there in my C file. So let me implement this. Let me convert these into function prototypes. It's fairly easy. There we go. And as good coding practice, I wrap this into a directive. That means if this file is already included somewhere, it should not be included again, because then I would actually redefine I2C write and the compiler would complain. Therefore, I wrap this into if-endef and give it a name, I2C start hatch. If this doesn't exist, then define it. And here is an endif. Okay, let's save this as header file. This is my I2C start dot hatch. And in the C file, I include this header file. See, start, so I'm using quotes because I'm not in the standard system directory, but in the local directory right here. Otherwise, the compiler will not find the header file. And I can remove these because they have already been defined. The C file contains now the implemented functionality, and the header file consists of my includes, my hash defines, and the function prototype. Now I have to do the same with I2C write. So I don't need this. I get rid of all this. I just leave the write behind and delete everything else. Let me save it. And let me wrap it in this if-endef. If-endef I2C. So I used to have two underscores here. It's totally up to you what you write. Just make sure it's the same as in the follow-up define. This function prototype and an endif. Therefore, the I2C write.c file contains only one function. That is I2C write. And let me include I2C write.h and remove this. Now we have four files. I2C start with its header file, as I2C write with a header file, and now we have to compile it somehow. The first step to compile these files into a library is to create object files. So we need to create 2 object files. That means the way I compile a library is exactly the way I compile a executable. And I stop the compilation right here to get object code. Since I don't have a main, the library cannot be executed and therefore executable code cannot be generated. I have to stop here. For that, let's create a Makefile, and I'm going to recycle a Makefile that we used for the blinking master. Just have to modify it. So first of all, we don't need upload functionality at all, so let me remove this in its entirety. Use the upload, and I don't create an executable nor hex file. What I also don't have are objects. I don't have the includes, and I don't have these kind of sources. Let me remove this. Okay. Now my target is lib I2C.a. A for being an archive or static library, and all libraries start with lib to indicate that they're libraries, and it's a standard. So the file name is important. It has to start with lib and end with a. How do I get this prerequisite? That means I have a target, lib I2C.a, which depends on 2 objects. This is I2C start.o and I2C write.o at the moment. I don't need this anymore. I don't have the hex file. I don't have the ELF. This rule addresses the object file generation. So we have a target any filename.o, and the prerequisite is the same filename.c, and I use the avr-gcc and these flags to compile the prerequisite, that is the filename.c, stop before the linker. That means I get object code, and the output will be the filename.o. That looks about right. Let's try it out and compile. And we get 2 O files, which are required for our library. So the question now is, how do I use these 2 object files and create my library? There's an article on the website for avr-libc. Just let me show you. I'm going to put the link into the resources folder and right here. And it says here how to design a library and creating a library. So we need avr-ar, rcs, then the library name, and the list of object modules. So let's try it out. My library is I2C.a, and these are my 2 modules. And I have a lib I2C.a. So that seems to work. Let me add this to the Makefile. This is the target, and we have the special variable, and these are all prerequisites, and I use another variable for that. So if I clean everything, I should also remove the library.a. Let's try it out. Make clean. So just out of interest, let's see what is inside. For that I can use object dump, and I want to show the source. And the headers. So I use object dump minus s minus h and then the library. And because lots of text will come, I just pipe it through less. So we have here our function I2C init, I2C start, all the content, I2C stop, and I2C write. So all files were integrated. How do I use this library? For that we have to adapt our blinking master. First I have to remove the I2C functionality, because this functionality is provided by the library. So I don't have this one anymore. I don't have this one. I don't have the TWI. And I remove everything that is related to I2C. There we go. Now I include the prototypes of I2C, and I need I2C start image, and I need the function prototype for I2C write, so that the compiler knows during compilation how this function is to be invoked, with which parameters it has, etc. And I2C write. If I compile this now, we can try. It does not know where I2C start.h is located. So if you invoke the compiler manually with the flag to show what it currently does, verbose flag, then you see that it searches for header files and these 4 directories, including my current one. However, I2C start.h is not included in my current one, but in I2C. That means I have to tell the compiler to add one more directory to this search path. And I do so by supplying the I parameter. So where's a good place? Here's the I dot, so I just added I.I2C. It can be a full path or like this, a relative path. So home, student, course, blink, quite long actually. So I just use a relative path. Let's see if it works now. So we added the I2C for our header files, and it seems to work. So we have an object file. So this object file calls I2C write and so on, but it doesn't have any idea how it looks like. So we can have a look at this. So let me pipe it through less. So there's no I2C at all in this entire file, but we see here some calls, and currently the calls are pointing to the main, and we did not create an executable so far. So what happens if I create an executable out of this? First, let me adapt the Makefile and add this include parameter, so that I don't forget. There we go. Let me compile it into an executable. And you see here these kind of error messages. It says here undefined reference to I2C init, I2C start, and so on. So these error messages come from the linker. It tells you where the error message occurred. So this is main plus 14 in hexadecimal format. There's this address, and 1A is the next one. So the linker tells you that it couldn't find how I2C, init, and so on are implemented. So we have to tell the compiler where the lib_I2C library is located. And to do that, let me do it manually first before I add it to the Makefile. We use the L parameter to add another directory to the search path of libraries, and in this case it's also I2C. And I have to tell to use the I2C library. And now this -L I2C means that the compiler automatically searches for a library file called lib_I2C.a, and that's why the file names are important. So let's see if it works. Oh, we don't get any error message anymore, and we have an ELF. Does it contain a functionality? ELF. So we have our vector table here. With a bad interrupt, we have our main, and we have here I2C init, I2C start, stop, and write directly included in our executable file, as we wanted it to be. Now, let me lose a few words why so many files are required. I could have written all the start and stop and init functions and the write functions into one single file. However, it's good coding practice to keep them separated, and let me show you why. So let us assume that a programmer is not calling I2C stop for whatever reason. So let me adapt the linking master, and I remove the I2C stop. Now it would be nice if the linker would recognize that I2C stop of the I2C library is not called any longer, and hence it is not integrated into the executable to save program memory space. Let's see if that's going to work. So I have to recompile. First, let me adapt the Makefile. So where do I compile? Compile it here. So I have to add -L to LIC2. And I have to add another parameter called lib. And this is then -L and also I2C. I think I don't need this actually. Let me add this here. And let me see if it works. Yeah, so it recompiled the theme into an object. It compiles the object into an executable. So this executable should not contain any I2C stop functionality any longer. So let us see if that is true. avr object dump source code and all the sections and this file. And let's pipe it through less. I2C. So I have I2C init, I2C start, I2C write, and there is no stop any longer. So the linker recognizes it and removes I2C stop from the integration into my executable. However, this library might also be used by others who compile their executable source code a little bit different. So let me show. Remember the function of these parameters? These parameters make sure that the linker is able to remove data and functions which are not used, since they are all in separate sections. That is for the compiler. And the linker can garbage collect these kind of sections which are not used. What happens if someone is not using this parameter? So the sections which are not used are still included in the library, as we can see here. I2C stop, and here it is, although there is no call to I2C stop. but the function is included and hence requires program memory space. What happens if I do the same with I2C write, which is in a separate file compared to I2C stop? Will it be still included? Remember, this file contains I2C init, I2C start, and I2C stop. And this file contains only I2C write. Now, what I did, I commented out the I2C write in our blinking master. And I want to know if the I2C write functionality is still included in our executable. Let me recompile. And let me recompile the executable without the garbage collector. And let me check if I2C write is still included. And it's not there anymore. So we have our I2C init, I2C start, and I2C stop, but no I2C write anymore. So you see, if you don't use this parameter for the linker, it includes all functions in that object file. That is init, start, and stop, even if they are not used. However, if the developer does not use these functions, the linker will not include the object file into the executable, as we have seen here. I do not use the I2C write, and the entire object is not used for creating the executable. It does not make any difference if you use this parameter. So even if you use, for instance, these two functions and not this one, it will be removed automatically from the executable code. However, you cannot rely that every developer is using this flag for the linker for whatever reason, and therefore it is good coding practice to have functions in a separated file. However, this does not apply to everything. Let me show you the documentation, and I have two important paragraphs here. It says here, ideally you want to design a library where only the functions that are called are the only functions to be linked into the final application. Obviously it makes the code size smaller. In order to do this, and depending on the way the linker works, write one function per code. That means, for instance, I2C write.c contains only I2C write. There are always exceptions to the rule. For instance, if you have functions which are commonly used together, in this case, for instance, malloc and free, or in our case, it was I2C init and I2C start. So the master need to set the frequency of the SCL line, and then the master is going to use the start function eventually, and a stop for the I2C bus. So we did that. However, the master does not necessarily need I2C write. It might only read from the slaves. In this case, only I2C read.o will be included. One important thing. The problem with ISRs is that they are never called in the source code anywhere. Hence, the linker might remove the ISR because there is no reference to that ISR. If the ISR is not included in the final executable, you have to combine the ISR with a function call that is included. For instance, I would not include the ISR for I2C into I2C write because I2C write might not be used, and therefore the ISR might not be included into the executable in the end. It is always a good idea to combine the ISR with functions which are definitely called. For instance, include a init function, which might even be empty, and aggregate it with the ISR. So here we could have ISR, TWI, vect, whatever this vector is, to make sure that this ISR is included. With this in mind, that's how you build a library, and you can add new functionalities into, for instance, I2C, and use this library in your other projects. That's all what I have for the practical session. Please have a look at the exercises, enjoy them and have fun. And once you're done, I will see you in the next chapter about SPI. See you in a bit, and thanks for watching.